Morning, everyone. I'm an associate professor from the Chongqing University of Technology in China, and I'm also a part-time professor of the Hubei University of Arts and Science. And my report is for the vibration energy harvesting and management for wireless sense networks in bridge health monitoring. So it's the outline, the background and the motivation of our work, and then the system architecture, and then the harvest structure and the theoretical model, and then the equivalent circuit and simulation. We will give the prototype implementation and preliminary results. The lifetime of very sense network is a very big challenge because the sensor nodes are powered by batteries with very limited amount of energy, and sometimes they are deployed in dangerous or human hard to reach places. So it's infeasible or even impossible to replace batteries for so many nodes. Energy harvesting has become more and more important as a way to prolong lifetime of and reduce maintenance cost of various networks. We have used solar and wind energy in some of our projects because of their widespread existence and high power density. It's a project of our project in China for the Milu deer monitoring. We use the solar panel for energy harvesting, and they can provide sufficient energy outdoors. But the solar and wind energy are not available in some scenarios. For example, we have some projects for structure monitoring, like the bridge structure monitoring, and some nodes are deployed inside the bridge, so we cannot use the solar and wind energy harvesting. So we need to find some other energy harvesting methods. Fortunately, vibration exists everywhere on the bridge. As a result, the vibration energy harvesting becomes a promising candidate to power the sensor nodes. Vibration energy has less power density than solar and the wind energy, but our sensor node, the power consumption of our sensor nodes is very high, such as the maxi nodes is about 30 to 100 milliwatts. Why vibration energy harvesting is feasible in the bridge structure monitoring? It's three reasons. The first is the vibration exists everywhere on the bridge. It's very large, and the vibration has enough latitude for harvesting. And the third, the sensor nodes sleep in most of the time and only work for short time, so we can use vibration energy harvesting. It's the sensor node architecture of our energy harvester. Compared with the traditional sensor nodes, there is additional energy harvester and the conditioning circuit and the storage device. We designed our prototype based on the P2 type MMC, the Micro Fiber Composite material, because of their flexibility on large deformation. And we use the cantilever beam structure to accommodate to the real bridge characteristics. And we use the energy prediction and management according to the application scenario. Because the energy harvested by vibration is low, so we need to collect enough information to help the energy usage. First, we should estimate the battery residual energy, and then we should predict, learning and predict the workload of the sensor nodes, and then we should learn and predict the vibration energy harvested. With this information, we can do energy prediction and management. We design our harvester by the cantilever beam structure because it's suitable for the real bridge structures. That is to say, the resonant frequencies of bridges are considered to maximum the energy harvested. The MC generates AC voltage, so an AC-DC rectifier have to be used. For simplicity, we use a full bridge rectifier, consists of 4 diodes and a capacitor. So the maximum harvest DC voltage of the energy harvester with 1 MSC patch bounded on the beam in Frickstone is this, and it's the maximum power, and we can use 2 MSC patches bounded to the front of the beam. So the 2 MSC patches can be connected in serial and in parallel. So for serial connection, the maximum power, and for parallel connection, the maximum power. So the following equivalent circuit is used to present our MNC harvester, and we use multisim to simulate the energy extraction and the storing procedure of the MNC harvester. It's some simulation results. For 1 MC connected, the output current is 15.45 microampere, and for 2 MFC parallel connected, the output current is 30.99 microampere, and for serial connected, the output current is 14.84 microampere. This is the prototype implementation, and we use the LTC 3588 to harvest and manage energy from vibration source, because it is a complete energy harvest solution optimized for low energy sources. And we use LTC 4071 to manage the charge of batteries, because it allows simple charging of polymer batteries from very low current. So it's a prototype of circuit and the PCB, and it's the experiment connection with the circuit and the MMC material. So when 4 to 5 Hertz vibration is applied, the output voltage waveform is shown. The output voltage of MC is alternating, and the peak-to-peak voltage is 6 volts, and which is related to the amplitude and the frequency of the applied vibration. Preliminary test is tried on a cable state bridge of our project, which the first natural frequency is 1.2785 Hertz. In this scenario, 0.4 microwatt every power can be obtained. With such power level, 1.1% duty cycle can be achieved, which is thought to be enough for our bridge structure monitor application, because most of nodes, center nodes sleep most of the time. Okay, it's some conclusion. In the future, more experiments will be conducted, and the sensor node integrated with the harvester will be used on our bridge structure monitoring applications. Thank you.